Okay, cool. So we're on section 1.4, and this is all about measurements and sort of like the history of measurements and how over time there needed to be a reason to sort of standardize measurements. So that's what this entire thing is about. I'm just going to go to the next page. And most of the world uses the metric system, except for like the US and a couple other very small countries like Liberia and Burma. And we're going to focus on dimensional analysis, okay? So we're going to be taking a look at converting from one unit to another. So dimensional analysis is just telling you that we're going to follow a specific method to solve problems when we're converting from one unit to another. We're going to be using conversion factors, which are sometimes called unit equations. They're the same thing. Conversion factors are fractions that are written with a denominator and a numerator that have equivalent values, but they are in different units. And I'm going to be pointing out a few that are exact and some that are not. So we're going to start with 1 inch is exactly the same length as 2.54 centimeters. Okay, so I'm going to emphasize the word exact here because inches is an English unit, centimeters is a metric unit. And when we're converting from one system of measurement to another, like English to metric and vice versa, these unit equations or conversion factors are not necessarily exact. However, this one is. So I need you to realize that anytime you're using 2.54 inches equals a centimeter, this is an exact conversion. And when it's an exact conversion, that means the numbers in it have infinite sig figs, and so we can't use those to determine the sig figs in our answer. So the number 1 is infinite sig figs, and the 2.54 is also infinite sig figs. Okay? Okay. Now, when we take a look at incorporating this into a conversion, so for instance, down here, we're looking at converting yards into centimeters. The units that go on the diagonal will be canceling out. Hence the reason they have yards written on the diagonal here. You know that you can convert yards into feet. And then you can convert feet into inches. And then you can convert inches into centimeters. Okay? So since yards and feet are both in the English system, that means that the number 1 and the 3 would have infinite sig figs. Okay. Also, inches and feet, both from the English system. So the number 12 has infinite sig figs. The number 1 has infinite sig figs. And then over here, we just talked about how this unit equation has infinite sig figs as well. So both of these are infinite. So the question is, how do I determine the sig figs in my final result? Well, you will be limited by whatever you begin with here. So here I have 3 significant figures in 1.00. And since everything else has infinite sig figs and I'm multiplying and dividing, that means my final answer will have the same number of sig figs as the fewest, which would be 3. Does this make sense? And I'm going to be pointing this out as we move along and do problems like this. Okay? Okay, let's take a look at the next page. On the next page, they focus on 1- and 2-step metric conversions, okay? So you know that the metric system is based upon powers of 10, and then those powers of 10 are given a specific prefix. So when you take a look here at all of these prefixes, we don't have to memorize all of them. The ones that I want you guys to pay attention to are going to be mega, so it's going to be here down to nano here. So I will not give you these. These are the ones that you need to know. Okay? And the powers of 10 are exact. So all of these, I'm just going to put a little arrow here. These are exact, which means they have infinite sig figs and won't influence the sig figs in a result. Okay? And anytime we are taking a look at things like length, mass, or volume, Length is a meter, which is a lowercase m. Mass is a gram, which is a lowercase g. And volume we previously talked about in another section, which is a capital L. Okay? So what I'm going to do is I'm going to focus on one-step metric conversions first. I'm going to give you the general outline. You may want to open up your chapter review packet that I gave you yesterday, because I also give you pictures in there that show you how to set up one-step metric conversions and two-step. It's the same thing every single time, okay? So let's do these one-step metric conversions first. There are two different types, okay? The first type is going to be a prefixed unit to a base unit. So these right here are the base units in the metric system. They are one-letter units. The prefixed unit will have two letters, right? So if I have something like whatever number that you're given, you're going to write it here with the prefixed unit after it, okay? And this is just the generic setup that I'm giving you, okay? On the diagonal, you will put the prefix unit, and then on the top, you will put the one-letter base unit. The number one always goes where the unit is with the prefix. So the number one will go here, and the power of 10 will go here every single time. So that means we will multiply across to get the answer with the base unit after it, okay? So let me give you an example. Well, we'll do an example on the next page. How about that? And then the other one-step problem, so this would be the first example. The second example will be a base unit to a prefixed unit. So whatever number that you're given, it will go here, and then you'll put the base unit, mess that up. You'll put the base unit here. On the diagonal, the base unit will go here, and then the prefixed unit will be on the top. You always write the number one where the prefixed unit is. So we would put the number one on the top this time, and then you would put the corresponding power of 10 down here on the bottom. Now, the reason why I teach it this way is because I'm actually going to start raising units to a power. So if you do it this way, everything else will fall into line, and it will work every single time. Okay? So before I give you the setup for the two-step problems, let's take a look at the practice problems on the next page. We're going to look at number 1 and number 2. Okay? We're ready? Okay. All right, let's take a look at 1 and 2. For number 1, it asks us to convert 16 seconds into kiloseconds. And this would be an example of a base, because it's a one-letter unit, to a prefix conversion. Okay? So here you're going to take your 16 seconds, write that down. You want to have seconds go on the diagonal because you're trying to cancel it. Kiloseconds is up on top. Okay, so I'm just emphasizing the fact that these units that I've highlighted have to match in order to cancel. Where would I put the number 1? On the top, because this is where your prefixed unit is. Okay, then you're going to look at the table for kilo. What power of 10 corresponds to kilo? 10 to the third. So you're going to write 10 to the third on the bottom. And then in your calculator, since the power of 10 is on the bottom, we're going to divide. So this is going to be 16 divided by second E 3, enter. And I believe you're going to get 0.016. Correct me if I'm wrong.
Yes.
Yes? Okay, now, in terms of significant figures, the number 1 and the power of 10, these have infinite sig figs. These are exact, okay? But I have 2 sig figs here in 16, so that's why I have 2 sig figs here in my answer. Okay. All right, do you want to try number 2 on your own? Okay, let's see what you guys come up with. Okay, I got 75 liters. Is that what you got? Okay, any questions on one-step metric conversions?
Is there any scenario where the answer has a different amount of sig figs than the original one, and you'd have to?
Yes, multi-step conversions. If I bring in, like if we have to use unit equations that are going from the metric system to the English system and it's not exact, that's when things are going to change. Okay? Okay, so can we go back and take a look at two-step now, and then we're done with the metric conversions? Okay, so I'm going to go ahead and give you, where do you have room to write some, do you have room at the bottom of the previous page to write the two-step setup? It's just one long setup. Okay, so let's go back here, and I will write it down here for you. Okay, so for two-step metric conversions, you're going to be given some sort of a number, and there will be a prefixed unit. Typically, two-step metric conversions are going from one prefix to another prefix in the metric system. So what makes them two-step is there is technically no direct conversion from one to the other. So we would have to go back to the base unit first and then convert from the base unit to the prefix. Okay, so for example, centigrams to nanograms, I can't do that in one step. I would have to go from centigrams to grams because that's this base unit here, and then grams to nanograms. So this would be step number one, and then this would be step number two. Okay, so we would have this set up like this, and this should also be in your review packet. So I would put the number one next to the prefix unit. The power of 10 would go here next to the base unit. And then I would have the base unit down here. And then the other prefixed unit here. The number one would go here. And then the corresponding power of 10 would go down here. And that would give me my answer. Okay, so that would be your setup every single time. I have to stop this video, and I will bring the words back. Hold on one second.